In this video, I am going to discuss about the meter bridge. Meter bridge is a device which works on the principle of Wheatstone bridge, and it is used to measure the resistance of a wire or unknown resistance of a wire. So simply you can say here, meter bridge is a device works on the principle of Wheatstone bridge, and it is used to determine the resistance of the wire. And remember this, meter bridge is more sensitive than post office box. Due to this reason, we prefer the meter bridge to find the resistance of the unknown wire. And in the meter bridge wire, AC is a wire of length 100 centimeter. It means length of this wire AC is 100 centimeter, which is mounted on a meter scale and fixed on a wooden board. On a wooden board, and on that wooden board there will be 1 meter scale, and on that scale a wire of AC be fixed with the 2 terminals at its end. And now R is a resistance box, and in the resistance box there are different keys. And all these keys are connected in series inside it here. It means with the help of this resistance box, you can take out any key. It means that resistance you are giving to this circuit. So R is a resistance box. ये एक resistance box है जिसमें ढेर सारी कीज लगी होती है डिफरेंट ओम की, और ये सारे कीज सब सीरीज में जुड़े रहते हैं. ये है unknown resistance, means the resistance which you want to determine. This one is called shunt, unknown resistance. Suppose G is a galvanometer. This one is called center zero galvanometer, and this one is called jockey. Jockey is a sliding, just like a pen, which will be slide over this wire AC. Cell, which is the source of current. This one is a rheostat, and rheostat is used to control the current in the circuit. And this one is a key, which is generally used for on and off. And this experiment is also mentioned in your syllabus. Means there is also one experiment to find the unknown resistance of a wire by using the meter bridge. So there we will do the same type of the connection. So again we will discuss this connection in experiment here. How can we connect this circuit here? Now, in this case, after connecting all these instruments, first we will check by putting the jockey at the point A and at the point C. Suppose this one is a center zero galvanometer. Suppose this one is a galvanometer, and this one is the needle of this galvanometer. And in the center zero galvanometer, 0 is in the middle. And after connecting the circuit, इस सर्किट को जोड़ने के बाद सबसे पहले हम ये चेक करते हैं कि हमारी सर्किट सही है या गलत है. तो इसके लिए क्या करते हैं? First we touch the jockey at point A and look the deflections in this galvanometer. Suppose when we touch the jockey at the point A, this galvanometer needle shows the deflection on left hand side of the 0. And again we touch the jockey at the point C. Suppose on touching the jockey at the point C, the needle of the galvanometer is giving the deflection right of the 0. It means A पे टच कराने पर और C पे टच कराने पर जॉकी को, अगर ये गैल्वोमीटर की नीडल 0 के दोनों साइड में डिफ्लेक्शन दे रही है, मतलब A पे टच कराने पे सपोज एक साइड और C पे टच कराने पे जस्ट उसका अपोजिट, इसका मतलब ये सर्किट सही है. Suppose when we touch the jockey at point B on the wire AC, and when we touch the jockey at the point B on the wire AC, suppose this galvanometer shows null deflection. Null deflection means the needle of the galvanometer lies at 0. And this is called null condition. What I am saying कि जब हम चौकी को मान लो इस वायर AC पे हम इस पॉइंट B पे टच कराते हैं तो उस समय ये गैलोमीटर का रीडिंग 0 पे आ जाता है। इसका मतलब ये गैलोमीटर क्या शो कर रहा है? नल डिफ्लेक्शन। And in this case you can say if R is the resistance taken from the resistance box, S is the resistance of a known wire, P is the resistance of this wire AB of length L, and Q is the resistance of wire BC of length 100 minus L. Then you know in the Wheatstone bridge, in the null condition or the condition for null deflection is what here? P by Q is equal to R by S. Here, since galvanometer is showing the null deflection, क्योंकि यहाँ पे galvanometer null deflection दे रहा है, इसका मतलब इस resistance जो resistance box से निकाला गया और इस unknown resistance S का रेशियो इस वायर AB के रेजिस्टेंस जो कि P है और इस वायर BC का रेजिस्टेंस जो कि Q है, इनके रेशियो के बराबर होगा। तभी आप कहेंगे कि गैलोमीटर हमारा क्या दे रहा है? नल डिफ्लेक्शन। And already I have told you, meter bridge is works on the principle of Wheatstone bridge. Now, if anybody asks to you which four resistances are participating in forming the Wheatstone bridge, so here resistance of this wire AB, which is P, resistance of wire BC, which is Q, resistance taken from the resistance box, and its resistance S. So, in the balanced condition of this bridge, or simply you can say, in the balanced condition, when this galvanometer shows null deflection, this point B is called what point? Null point. So, by principle of Wheatstone bridge, we have P by Q is equal to R by S, where P is the resistance of this wire AB, and what is the length of this wire AB is L. So, simply you can say resistance of wire AB and resistance of wire AB, what you have taken? P. Dear student, you know one formula. R is equal to rho into L upon A. Already I have given in the previous video where R is resistance, rho is specific resistance, L length of the wire, and A is its area of cross section. And you know for this wire A to C, area of cross section is same and material is same, so rho is also same. Then you can say R is directly proportional to L. So simply resistance of wire AB and whose resistance you have taken P, use this formula, rho into length of this wire is L and suppose area is P. Similarly, the resistance of wire BC, and what is taken the resistance of this wire BC? Suppose this resistance is Q, so you can write Q is equal to, again apply the same formula, rho into 100 minus L. Now here length is 100 minus L upon. And from here you can say P by Q. So P by Q is equal to how much? P by Q becomes rho into L by A upon rho into 100 minus L by A. And from here rho is cancelled by rho. So we can write here L upon A into A upon 100 minus L. A is cancelled by A. So simply we can say here P by Q is equal to L upon 100 minus L. So P upon Q is how much? L upon 100 minus L. So by the balance condition of the Wheatstone P by Q is equal to R by S, we can write here L upon 100 minus L is equal to R by Our aim is to find the value of the unknown resistance S. So now we can write here S is equal to 100 minus L upon L. And in this way, by using this formula, direct we can find the value of the unknown resistance for the different value of R. जब इस R मीन्स इस रेजिस्टेंस बॉक्स से हम अलग अलग रेजिस्टेंस निकालेंगे तो हर बार हमको ये नल डिफ्लेक्शन वाली जो लेंथ है वो भी अलग अलग आएगी. But after calculation, the value of S will comes in. So in this way, you can say here S is equal to 100 minus L into resistance taken from resistance box upon L. So simply you can say by using this formula, we can find the value of the unknown resistance. Now in this experiment, what is the source of error or what precaution we will take? This one is also very important here. So first precaution, what we will take? The resistance taken from this resistance box is chosen in such a way. इसका मतलब इस रेजिस्टेंस बॉक्स में से हम ऐसा रेजिस्टेंस सेलेक्ट करते हैं कि जिससे कि नल पॉइंट वो लगभग मिडिल में आए इस वायर एसी के. एंड इन दिस केस error in this experiment will be what here? Minimum or least error will come here. So first precaution is what here? कि the resistance taken from this resistance box is always chosen in such a way so the null point be obtained in the middle of this wire AC, and in this case you can say the error in this experiment will be least or minimum. Second precaution what we will take? We will not allow the current in this wire AC for a long time. मतलब हम बहुत देर तक इस वायर AC में हम करंट को अलाउ नहीं करेंगे. Otherwise, the wire AC becomes hot. And you know, on increasing the temperature, the resistance of a wire is also increases. So, when this wire AC becomes hot, then its resistance may be changed or its resistance may be increased. So, second precaution is what? The current in this wire AC is not allowed for a long time. Otherwise, the wire AC becomes hot and its resistance may be changed. Third precaution, to avoid the damage of this galvanometer. कभी-कभी गैल्वेनोमीटर में इतनी ज्यादा करंट फ्लो कर जाती है कि गैल्वेनोमीटर जब एक तरफ डिफ्लेक्ट होती है तो उसकी निडल टिल्ट कर जाती है. तो to avoid the damage of this galvanometer, in the beginning we attach a wire or we attach a shunt across it. This one is called shunted galvanometer or shunt across it. And at the null deflection point, जहां पे null deflection point जब मिलने वाला रहता है तब उस वायर को जो गैल्वेनोमीटर के क्रॉस हम जोड़ते हैं उसको क्या करते हैं? निकाल देते हैं. और इस तरह से हम इस गैल्वेनोमीटर को डैमेज से क्या कर सकते हैं? बचा सकते हैं. And fourth precaution is what here? This jockey should not be rubbed on the wire AC. इस वायर AC पे जॉकी को बहुत रगड़ना नहीं चाहिए. Otherwise, the thickness of this wire AC is changed. And when the thickness be changed, then in this way also you can say the resistance of this wire AC will also change. In this way, when we will do the experiment, then always we will keep all these precautions in mind here. Especially this one is sure you keep here. Do not allow the current in wire AC for a long time. Don't rub the wire, don't rub the jockey on the wire AC. मैं कह जरूर रहा हूँ कि इस पर रब नहीं करना, लेकिन मैं जानता हूँ during the experiment all of you only start to rub, but please you avoid it. Otherwise, the thickness of this wire AC will change, and when thickness will change, then resistance will also change here. So this one is whole about the meter bridge and its precaution, what precaution we will take during this experiment here. Dear student, tomorrow I will give you the next video regarding the last topic of this chapter, which is the potentiometer, and it is very important, and sure one question will be asked either from the meter bridge or potentiometer in your board exam. Thank you.